Welcome everyone. It is my great pleasure today to welcome Matt Maloney from City of Hope with an interesting presentation of how sktime has been used inside their organization. It's great to have you here, Matt. Over to you.
Yeah, thanks. Thanks for the invitation to present, and for all the work you've done on sktime. So yeah, let's get started. This will be a very applied presentation because the work I do is very applied. And I have a few slides and then can open it up to discussion. And I also have a little kind of demonstration Jupyter notebook if you all want to see a couple of things. I'm not sharing any data from City of Hope. I work on the business and operations side, and so the data that I typically work on is not something I could share. But I want to kind of introduce you all to how I've used sktime to help my team be more efficient and develop some pretty good forecasting capabilities for City of Hope. So what's City of Hope? It's not actually a city. It's the name of a system of comprehensive cancer treatment centers and community clinics throughout the United States. The original site is in Southern California in the eastern part of Los Angeles County. And when I do work from the office, it's from this area here. And it's a beautiful campus. We have some gardens there that are quite nice. And then in 2022, we acquired another system of cancer treatment centers. And so now we have hospitals also in 3 other states. So Illinois, Arizona, and Georgia. And there's also, in addition to providing treatment and patient care, there's also a research institute that does have graduate students on the LA campus. So about me and my work, I work remotely from Fort Collins, Colorado. I have to go to Los Angeles for about 1 week a quarter. So I'm down in LA. Yeah, about every 3 months or so at the site I just showed you all. Undergrad from University of North Carolina and PhD in economics from the University of Wyoming. And then before grad school and for a year after grad school, I worked in finance. So for a little while after grad school, I was doing some time series modeling for a large bank in the United States. So interest rate risk management, stress testing were the applications of the work I was doing. And then at City of Hope, I lead a small team of data scientists. There are 4 of us, including myself, that we support operations and business functions. So there are other teams of data scientists to support research applications, and then a 3rd team that supports applications that sort of directly affect patient care. So what does that mean? Our team supports products in a few different areas. So clinical documentation, coding, and billing. I'll talk a little bit more about this in the next slide, because in the United States, this is all very complicated, certainly more so, I think, than the rest of the world. So, in some ways, there's more opportunity for us to work there, but it can also be a little bit confusing. Clinical research operations. So, many of our patients are enrolled in clinical research trials for cancer treatments, and there's a lot of operational work that goes into matching patients with clinical trials, screening them, that sort of work. And then business planning and strategy. So this is where we've been using sktime because there's time series forecasting requests that come to us for this domain. And we've also done a little bit of work in cybersecurity and have a little bit of work supporting the philanthropic part of our organization. So fundraising. Any questions for me so far? So let me talk about the forecasting task that sort of started this journey that eventually led us to begin using sktime. So in early 2021, our team was asked to forecast cash the organization receives from health insurers and patients. So I'm going to spend just a little bit of time trying to give a high-level overview of why this is even necessary. So there are many different health insurance organizations, and typically these health insurance organizations in the United States are where we receive our money. So a patient comes in, we verify that they have insurance, and then when they actually go and receive care, there's a team that they call it coding, not like computer coding, but writing down codes for the procedures and supplies that the patient received during the visit. And then a team kind of converts that information into an amount that they would owe for that. And then there's a process then of sending out, paperwork, we call this like claims submission and processing to one of these insurance companies that then in a period of time that could be a couple of weeks, but then it could be a process that in some cases takes much longer for a very expensive account. I've seen well over a year. We will receive payment back from the insurance company, at which point, if they, pay us in full, that works. But in some cases, they may say, no, we don't actually owe you for this. This is denied for some reason. There are a few different reasons they can deny payment. Sometimes it's just a lack of documentation or something like that. So we will then go through the cycle again. So what it makes, it makes for a system where the timing of the payment we receive can be somewhat irregular. And then the final step is if there's some remaining amount that the insurance company did not cover, we would receive payment from the patients themselves in some cases. Usually this is a very small percentage of the overall bill, though. I know this is not what you all are probably here to hear about, is the U.S. healthcare system, but I think it helps explain why this is even a job in the first place. So what they were asking for is a kind of 1 month forecasting horizon with daily time steps. So they want to be able to predict, what amount of cash will we receive for the next month. Was that a question? I thought I heard something.
Okay. No, I'm sorry.
Oh, that's okay. So daily time steps, this part is kind of important because, while they're overall interested in the accuracy of, what are we going to collect over the next month, throughout the course of the month, being able to track it on a daily basis helps to make adjustments to the business, right? So they can say, oh, maybe we're looking a little behind schedule for this one payer, so we'll maybe shift resources towards this, billing and denials management process for a certain payer, that kind of thing. So the daily time steps are actually important for the day-to-day usage of the product. And then The other requirement was it outperforms competing solutions. So when they first brought us in, there were two competing solutions, one from uh, uh, a large, healthcare software company, and then another one where they were working with a consultant, and the consultant, was doing something in Excel that wasn't very accurate. So they asked me to develop something new. So as I've said, challenges, inherent unpredictability in payment timing, and constantly evolving billing processes. So, maybe a general way to say this is the data generating process is always changing as the business changes. A need to flexibly incorporate new features. A lot of this is, working with the stakeholders, and they'll say, oh, did you try factoring in X, Y, and Z? And I'll say, no, but we can run that experiment if it's something they really want to see. The sort of periodicity and interaction effects. So some of these payers will pay every day. Some of them only pay certain days of the week. So you get kind of interesting interaction effects also between like the day of the week and the holidays. So, if a payer pays every day and there's a holiday, maybe you'll receive more cash the next day. But if it's a payer that only pays once a week, well, do they end up paying the next weekday, or does it wait until the following week? So that could be a little challenging. And then limited data for some series. So you'll see that this is actually a hierarchical forecasting task, because we're doing it by the 15 insurance companies and then also for a few different business units. And for some of these, we do not have a lot of history. So first version in late 2021, we were able to meet the requirements using a tree-based method. This is, I think, when we were developing this, about the time, some of the first white papers were coming out about the M5 competition. It's a little shout out to that, because that was helpful in influencing our design. And I enjoyed doing something new. Prior to this, I'd mostly been using more traditional time series and econometrics methods. So this was something a little new. And I'll kind of go quickly through this. Early 2021, as I said, the task was assigned to our team. Late 2021, we implemented this non-sktime tree-based solution. And then I think early 2022 is when it became clear that I needed a more flexible and easier to maintain code base for this. Because it was about this time where we made that business acquisition, and I was being asked to expand the forecasting tool to incorporate these new business units. And I said maintaining code or running experiments was too time consuming. This sort of depends, right, on what else you have going on, right? Too time consuming depends on how much time you have to allocate to each task. And something I should say about our team is, you saw all of those areas that we support. And right now, I looked before this meeting, and my team, we have tasks, I think, for this quarter. We have tasks we need to get done for like 14 different products just this quarter. And my team, we're data scientists, but we also, we usually do all the like UI implementation. Sometimes it's a simple dashboard, sometimes it's a little more sophisticated. And then we also are involved to some extent in the DevOps and data engineering. So we are a small team at an organization that's growing and trying to adopt a lot of these new technologies, but we're very applied, and we're managing many different projects. So anything that can make us more efficient, it's really important. So in late 2022, we began learning sktime, and developing, that's a typo, developing a new solution. It should be A instead of up, sorry about that. And then sktime-based solution goes into production in late 2023. 2024, we went into production with the 3 new regions and a new business division. And then looking forward, what I'm aiming to do as we've improved this solution and sktime-based code base is extend this to other of our like enterprise performance metrics and KPIs. So you can think of something like one thing the organization tracks is new patient visits by location and disease type. All right, actually, any questions before I move to the next slide? All right. So why sktime? I've hit on this a little bit already, but there was kind of high complexity of our custom code. So, cost of development, maintenance, and validation, you can think writing tests and that kind of thing. And in the original solution, I guess just because we weren't aware necessarily of everything that was out there, we did write our own, time series cross validation generator as an example. And then, some of the data preprocessing and feature engineering to allow us to use a tree-based method. But that was, kind of costly. And a little bit more difficult to involve and onboard other staff into the work because, everything we're developing ourselves, we'd have to document, whereas I guess probably as most of the documentation for sktime is very good now, and it's a huge resource for us when doing development now. So, powerful time series specific capabilities, like now that we're using sktime. So, for example, expanding window splitter, all the reduction for tree-based methods and, extensive selection that's always growing. And I'm not even close to aware of all the options that are there now of, transformations and forecasters with the unified API. And thorough documentation, like I said. So, and then the other thing is just we didn't have enough flexibility, so we get a new region or business unit and something would be a little bit different. And it was really costly to run experiments and do any, benchmarking. Maybe we want to try this like slightly more sophisticated approach, but we want to benchmark it against something, simple, a REMA or something, right? Without the sort of plug and play nature, it required a lot of time to do that. And there wasn't enough shared, code across, our forecasting tasks. So, as I started in 2022 thinking about how to extend this to those other locations, it was I realized it wasn't going to be very efficient. And then so, sktime has this flexible plug and play framework. It's a similar, it's very familiar to someone who's already worked with sklearn. So, that's, most data scientists, I would hire or work with have that familiarity already. And it allows for pretty easy experimentation and benchmarking. And I'll also say that the extensive hyperparameter tuning and model selection options, I've listed a few that we've used there, sort of allows us to do this sort of pseudo auto ML, solution where we narrow the scope of what the types of model specifications and pipelines we will try, so we have a lot of control. But then also we can sort of do these really expansive experiments over different pipelines and sort of use compute, to find the best solution rather than, relying on our own expertise, I guess. Any questions about this before I move on? Okay, so one customization that I've done, and this is something that is still a work in progress, and I don't think it's really something that would be generalizable to, any forecasting pipeline or task. It's really a sort of generalization, um, an enhancement we've made to just make us more efficient in implementing this into production. And so again, I don't think this is a general, something that could be used generally, but it's something that's really helped us for the tasks we're doing. So I've kind of created this even higher level wrapper for some of the sktime capabilities called like a forecasting recipe. I'm stealing the terminology a little bit from tidy models, if anybody has used that in R. Um, I think of it as sort of a broader pipeline. So it's a pipeline plus some other capabilities. Um, so one of the things. So essentially, I've created a forecasting recipe class that stores some attributes about the forecasting task. For example, what's the frequency, and has methods for that I customize for importing source data. So typically, um, this is a SQL query we're writing to hit our Snowflake instance. Um, and this becomes especially helpful for our, running this in production every day because, we're just running this method with new parameters for the date range to bring in the data that we need to update the forecaster. Data preprocessing. So by preprocessing, I mean preprocessing that doesn't require, knowledge of the distributions of any of the variables. So, no, not like something that you would want to contain in the pipeline itself to avoid leakage. Adding individual pipeline components. So sort of it gives me the capability to sort of add, okay, if I want some transforms for my target, I can add those individually. If I want some transforms for some exogenous features, and it'll sort of build those pipelines in the background. So I don't necessarily have to, for example, like write the string to reference a certain hyperparameter that may have a bunch of, that may end up having, depending on what the final pipeline looks like several prefixes. And building a complete forecaster from components. So sort of, I kind of add these I'm able to add these pipeline components more individually. And then, I just sort of have like a build function that will then, depending on what I'm trying to do, apply the pipeline constructors automatically and then update prepend the strings of the transform for the hyperparameters automatically. So, and to kind of give a visual on how this helps us is, I end up having sort of three main files. One is a kind of a config file that's just YAML that contains some of the recipe parameters and then also some training parameters. And then this is the most specific, right? So this might be specific to every single, this, in most cases it's not, but this could be specific to like every insurance company, as I was, pointing out. So this could be specific to every individual time series. And then a recipe, it's a little more general. It's for building this forecasting recipe object. So this, might be the same for a region, but it might be a little different for two different regions. And then I have a training script that's actually the same, essentially the same for every task I'm doing because it just works off the recipe methods primarily. So I imagine there are probably maybe some questions about this. I'm kind of assuming this is a group that mostly already has familiarity with sktime, because otherwise this would be a lot of information. But any questions about this?
Well, I actually do have one. So this sounds extremely interesting. And I was wondering if this is something you could share, at least in an abstract form, the forecasting recipe, I mean. Or is this like the secret sauce kind of thing for you?
No, I can absolutely share this. And I have a demo. I mean, I will say that the recipe is very much a work in progress. It's something that I was, tinkering with that class up until today, and I'm not really a great software, engineer. So it's functional for us, but it's not something that it would probably be you know um, ready at this point. But I'm happy to share it. Yeah, there's no secret sauce in the
Yeah.
recipe class itself.
Yeah, well, I don't think it needs to win a beauty contest. It's I think the idea that I would be personally most interested in. So what's the conceptual thinking behind that? And of course, for that, the Python code
Yep.
itself would be really useful.
Yeah, I can share that with you. I have a uh, Jupyter notebook, or I have just a simple demo of how this might be used. So we can also hop into that here in a minute if that would be useful for this audience.
I would be all in for it.
Okay, then let's do that. I'll do one more quick slide, and then I can jump into that and kind of show you what I've been working on there with the recipe. Um, so I don't know how interested this group will be in this, but I think it's I wanted to highlight, how there's a lot of extra work that goes into us. So there's a lot of extra, not extra work, but there's a lot of work we do that isn't the core data science development. It's also building the architecture to sort of turn this into a production solution that runs reliably every day. So I won't spend too much time on this, but I thought this audience might find this a little bit interesting. So uh, City of Hope uses Azure as our cloud, platform and service provider. So we've got our work in Azure repos now. Azure also owns GitHub now, so we can kind of we actually have a few things in GitHub, but mostly Azure for my team. Um, and then the way we've set this up, which, I have no idea if this is the right way to do it, but this is the way we've done it, trying to be data scientists wearing a dev, more of a DevOps hat. We're running these forecasts every day with a daily scheduled job, runs on an Azure agent. That data importer method you're talking about, sorry, I was talking about in the last slide, pulls in from our Snowflake production database, runs the predictions, then we write the updated forecast back to production database. And then we have a POSIT server we maintain. So some of our um, sort of user interfaces are Python based, some of them are R based. Um, um, and this is kind of just how we run things every day. And then for a pull request, that would be maybe a new model version or something, we'll create a pull request, do a review, but then we have a parallel QA pipeline, so we can kind of test everything all the way down to a QA user interface before we merge into master, and it becomes the thing that we run every day. And then as far as this, here it says Azure agent runs pipeline. We have a few stages, right? We pull the Docker container from an Azure container registry. Then I actually have a step for testing whether the data from the day before has actually been that we need as an input in the forecasting process is available. So, typically by the time we run our scheduled job, it's ready, but sometimes it isn't. We're working on building a direct trigger for that, but we don't have that now. So I just run a little test to make sure that the data is fresh. And then, the prediction process is load the recipe, load the fitted, pipeline, and import, the data we need to update the forecast, run the prediction task, write the forecast to Snowflake. So, not a super complicated process, but this is how we do it now. So a couple challenges. Learning the forecasting structure, this is just, accessing individual elements, as I create, the more sophisticated pipelines, was a little bit of a learning curve for me. And that's one of the things that I think that forecasting recipe helps a little bit with. And then update methods. I haven't had a ton of success getting these to work reliably enough in our production pipeline. So what I do is I kind of just bring in the data and just retrain the model rather than running an update method for the daily runs. All right. Sorry, I'm gonna hop into that Jupyter notebook now, unless there are any questions.
I think this is maybe a good opportunity for also contributors or developers to talk about those challenges. So I have, for instance, the question, you say update method doesn't work reliably, because I would be interested to understand your exact use case, or just trying to use update and it breaks, or what exactly is the nature of the difficulties?
Yeah, it's been a while since I kind of went through this process. I just was getting a lot of errors. I can't remember exactly what the errors were. So yeah, I apologize. I don't have the details on hand for what errors were being thrown, but I just remember trying to build that for production run with the update method. And as I said on the slide, it was probably user error, most likely. But this was probably almost a year ago when I made the decision to sort of just opt for retraining from scratch. So
we shouldn't assume user error. So I would be really happy to dive into the issue offline if you have the time, just to see what we can what we can identify as potential issues here, and then convert them into issues possibly, or maybe there's a bigger design problem going on. There's a question from Mridul.
Yeah. Hi, Matt. Nice presentation till now. My question was, in the previous slide, you told us about how we can get the data, process the data, and then use Azure to, basically perform dev operations and then deploy to the production. In that slide, you also mentioned about something called as data freshness algorithm, like it keeps refreshing the data to keep it up to date. So my question was regarding the errors which we can expect while refreshing the data. So I think there is a term which is known as data contracts. I think it basically means when the unexpected schema changes are happening in the database, and then how do we need to handle those issues? My question was that.
So I can speak to that. So I think I'll clarify a little bit what's happening there. So if I'm understanding your question correctly, I think it's aligned with what I was saying, but let me clarify really quickly, which is we have a process that in the morning takes data out of our source system and then loads it into our Snowflake instance. And usually the issue we're dealing with is that load has not completed for some reason, at least for the tables that we're dependent on. And so there's a check just to see, when's the last time this this table the source table we need was updated. So there's not anything built in that checks for any kind of like data drift or anomalous data. It's just checking it really if that table has been updated on time. So we don't have, I don't know if this is exactly what you're getting at, but we don't have anything to look for anomalous data or data drift kind of problems in that step.
Yeah, so basically you're saying the updation takes place when you just update the timestamps of the data.
Oh, you're saying trigger the run with that.
Oh, yeah, I got it. Thank you.
Okay, yeah, that makes sense. Thanks for your question.
Thank you.
And Franz, I was going to say let me see when I have time if I can recreate those errors that I was getting related to update methods. So when I have a chance, I'll circle back to that and see if I could replicate those errors. In which case, I can reach out to you and give you more concrete information about the problem.
Yeah, that would be great. I mean, great not in the sense that they are errors, but it's better to know about errors than not know about them.
All right, let me maybe I know we're getting close to the end of our time here.
We
but
still
maybe
have 20 minutes. That's a lot of time.
Okay. Well, I mean, I guess I was trying to leave room for more Q&A, but I can jump into the notebook here. I think that might be a good way to spend some of the rest of our time.
It's an interactive session anyway, so
yeah.
Q&A, fire away.
So I decided to do a little bit of a demo on again, very much a work in progress, but I threw together a quick demo using the sort of classic airline passengers time series. So I think it might actually be easier to start a little lower in the notebook here, because this is an area where I'm defining some of the recipe components.
That's interesting. So can I just quickly comment just for if the developers in the call? So things I'm spotting. So in cell 9, that looks a little bit like the new data loader class design by Felipe. And cell number 12, yeah, it looks a little bit like the craft method from the registry. Yeah, thanks.
Yeah, and I wouldn't be surprised if there are, things in here that have since been, that there are solutions I'm unaware of in sktime.
Yeah, it's probably not as integrated as you want it to be.
Okay.
I think it's more like scattered across the place and not as the recipe you're probably going to show now.
Okay. But commenting on one of the challenges, I said that one of the things I like about breaking it up this way is I can just specify the hyperparameter, like reference keys here, and without worrying about the whatever prefixes will need to be there ultimately.
Yeah, that's annoying, isn't it?
Well,
I
it's
wonder why
necessary.
scikit-learn hasn't done that.
It's I mean, it's necessary, right? Everything needs a unique address, right? And then this is kind of I wasn't trying to do
Yeah, but you
here
can use
any.
suffixes. Did you know that you can use suffixes only in sktime if the suffix is unique? So you just write lags, then it works.
Oh, I didn't know that. That's new to me. But that's not the case in sklearn.
It's a case in sktime because we
All
rely
right.
on scikit base, which is a redesign.
And so I'll show one other part here, which is the transformations of why I have the target. I'm not giving any kind of instructions here on how to do build the best forecasting model, but I thought this was a fun way to show sort of this like pseudo auto ML capability by using optional pass-through. I sort of know I want to detrend Y, but I'm not sure how exactly I want to do those transformations. So I can kind of pack a lot into there. But yeah, thanks for providing me the feedback on the ability to reference if the suffix is unique. I didn't know
Fingers
about that.
crossed, it should work.
So, so here's like what the kind of workflow would look like. And please give me, lots of feedback around, I don't know, even Python code formatting, because, I do the best I can, but wear a lot of hats here. So recipe parameters, this is, if you remember from my diagram in the slides, this is one of the things that would live in that YAML file that I store as sort of a config file. But information about, some of the recipe characteristics that I might want to know later. And then right now, I'm sort of just binding these as methods to the class, but I think that really there should be a data importer class that.
Is that like the data loader in Torch? This looks a bit like the data loader in Torch. Is that an inspiration?
I haven't. It wasn't a direct inspiration, but I guess it's solving a similar problem. Convergent evolution. I have not used PyTorch in a very long time.
Yeah, we wait for 5 more years and everything will be crabs.
Yeah. Things change so quickly that these days with well, the first thing I should say is I'm mostly in a management role at this point, and my individual contributions get smaller and smaller. But also at this point, I just try to let the problems I encounter and am assigned drive drive what new technologies I learn. Similar to this project. So yeah, it'll be interesting to see. You learn something now, and the correct approach will be different in 3 years. Or the state-of-the-art approach, I should say. So this, the assigning some of the attributes to the object, the data importer, a preprocessor, and then known feature creator. So I found a need, this is a little clumsy, but I found a need to, when building these recipes, treat if I have a feature that I know the future values, like a holiday or something, versus one that I might need to forecast, if I'm still, if I'm not doing a multivariate forecaster, but I still want to include a feature that I might need to use forecast X for. So I've sort of created this distinction between the X's that I would know a future value for versus those that I wouldn't, and I would have to bring in the forecast X capability. And so here's I've just kind of printed out, some of the variables from the recipe object. And right now there's nothing assigned for the core forecaster because I thought it was easier to see, without it. But I have a little update method to assign the hyperparameters, the Y core forecaster and the Y hyperparameters and the transformations for Y here. I'm not doing a lot with X in this example. So it was just easier to look at the printout before I added these as attributes to the class. So So I'm updating it to so that it has these parts of the pipeline. And then I have the build full pipeline method. That's still very much a work in progress, but kind of glues everything together. This ID transform is for that 1x feature that I'm including, because I just have the ID transformer as sort of a placeholder. That isn't really necessary, but was kind of helpful. So then what does this look like? Then I have training parameters, which are, a little bit conceptually distinct from the recipe parameters. So what does this look like? I do the data importer. I do the data preprocessing. Just printouts. I imagine many of you have seen this air passengers data set before. Split into train and test. Do the CV generator with.
I've never seen it before. Can you explain it?
Oh, you haven't? Okay, sorry.
No, I'm just joking. I'm just joking.
Oh, okay.
Everyone and their mother uses this in their tutorials, I suppose, because it's so easy to grab from the internet.
Right. Yeah. So I guess it's a little bit boring, but I
but
think
that's not the exciting part. The exciting part is your code, obviously.
Yeah. So yeah, just using the temporal train test split, another great feature. And the expanding window splitter, which again replaced something we were doing originally with our own custom CV generator. So this is much better. Doing the forecasting randomized search CV to train and tune the pipeline. And then you'll see I run evaluate on the best forecaster. I know I could extract it from this, but sometimes I just find it a little easier to run this evaluate again. Yeah, so I don't have like a predicting on a test set here, which would be the most analogous, to what we're doing every day in production. But like I said, a few of these methods from the recipe, like the data importer and the preprocessor, are really helpful for that daily pipeline where we're updating. So it not only makes the training script cleaner, like this, it also makes that daily prediction script really clean to have the recipe set up like this. So anyway, this is my example. I don't know if you all have any questions now, but it looks like we have a few minutes left, and I wanted to leave time for lots of questions.
Yeah, very, very fascinating. The recipe, I'll have to digest it a little bit. Any question, anyone else? So you have to click the unmute button if you have any questions. Okay, well, if there aren't any questions, what I'll do now is I'll turn off the recording in a moment, and then I'll ask this question again. And for now, I'll thank Matt. Thanks a lot for a highly interesting presentation, for the interesting discussions. Hope to see you around on sktime, and we have a meetup like this. So some have presentations like today. Other weeks we have free community collaboration sessions. Looking forward to see everyone there, perhaps. Bye-bye.
Thank you.